Okay, welcome ACT Math Preppers. Today is day 26. You should have your pink sheet here. And we are going to work on the bell ringer. So take about 5 minutes, 5 to 10 minutes, hit pause on your button and work on the bell ringer activity, and then unpause and we'll go over the answers. Okay, welcome back. So let's look here. If we look at our answers, we have, in this first one, we have 2. The x is listed twice. There's 2 variables. They equal, so that means we add them. 3 plus 4 is 7. We have the y's listed twice. There's 2 variables because remember there is an understood 1 here. So we add them. Same thing here, we'll be adding. If you get over here, this one's very interesting because this looks very, very complicated, but you can see the answer is simple. Because if you do this here, we can transfer this to a cubed over b, because b divided by b squared is b. And then it's same, change, flip. So we flip that second one. Remember that was the 3. And so then those cancel out. So this is a great example of why we want to simplify an equation, because it's a whole lot easier to do a cubed. We don't even need to know what b is to solve this one. When we get down to this bottom row, this is where x is listed only 1 time, but there's 2 exponents. So this is where you're going to multiply. You're going to distribute that 3 and multiply it through. This one can be done several different ways. You can simplify what's in the parentheses first, then square it, or you can square everything and then simplify. And I prefer to simplify inside the parentheses first, then square it. And here the best thing to do is to distribute the exponent here first. And then, because that's going to be multiplying your exponents, then you're going to be adding the exponents. Okay, so slope, equation of a line, and graph of a line. This is going to be something that as long as you're taking a math class, you're going to need to do this. So if you're unsure and you're not good at it, you best learn it now because it's not going anywhere. So what is slope? Slope is the change in y over the change in x. You've heard the saying, it's rise over run. So how far it goes up or down over how far it goes left and right. Slope is usually represented by the variable m. When we see m equals, that's slope. Now, 2 things that are really helpful to know about slopes of linear equations. If it's a positive slope, it's like starting on the left and going upstairs. That would be going from the first floor to the second floor. That'd be adding 1, so it's positive. If it's going down left to right, that would be like going from the second floor to the first floor, would be subtracting a floor. That's a negative slope. And it's really good to know this because especially on multiple choice tests, if you know what the slope is, you usually can eliminate 2, if not 3 of the answers. Now, really quickly, I'm going to go back. The equation for the slope of a line is y2 minus y1 over x2 minus x1. So if you are given any 2 points on a line, you should be able to calculate the slope. And if you have the slope in 1 point, you should be able to write the equation of the line. And again, I've tutored kids in college algebra, calculus. This doesn't go away. Slope is a concept you need to know. Okay, you definitely need to know it for geometry and algebra 2 and whatever senior math you're taking. Okay, so let's erase the pen. 2 things that you need to know is if you have a horizontal line, that has a 0 slope. I like to remember this. This is a horizontal line. It's like the floor. Can I walk on it? Yes. Yes, it has a slope. Is this have an incline going up or down any? No, it's at 0. So this line has a slope and it is 0. If we calculated it, you're going to end up getting something like 0 over 10, which 0 divided by anything is 0. Vertical line. Now, I think of this as a wall. Okay, so ooh, look at this tree here by me. Can I walk up this tree? Can't say no, but you can't say yes. If all of a sudden I develop super Bugs Life powers and I'm an ant, could I walk up it? Yes, but we haven't invented that yet. What about suction cup shoes? What about rappelling equipment? Could I walk up it? There's a whole lot of undefined ways that I might be able to do it. Can't say yes, can't say no. This is an undefined slope. How can you walk up a vertical wall? How can I walk up this tree? Nobody's really defined how to do it yet. It's not impossible, but it's not probable right now. So vertical lines have an undefined slope because this is going to be where you get the slope is equal to a number divided by 0. And we know we can't divide by 0, so that's undefined. That's where we get those two from. Now, for the equation of a line, the equation is usually in y-intercept form or slope-intercept form. That's y equals mx plus b, where m is the slope and b is where it crosses the y-axis. In a linear equation, we have the variables x and y. They deal with the coordinate plane, the x and y axis. And m, again, represents the slope of the line. So this coefficient in front of x, this is going to be whatever our slope is. This b here, this is where it crosses the y-axis. So it's always going to be 0, comma, whatever b is. Whatever that b is, that will be the second coordinate. Here's our example. If we've got an equation of a line, they're giving us the slope, this is m, crosses the y-axis at 5, this is b. We just plug it into this equation here. And you're going to get y equals, slope is 2/3, plug in that should be an x. Oh, that's a typo, that should be an x. 2/3 x plus 5. Now, you also need to remember when we talk about slope, there's two important ones. Parallel lines are going to have the exact same slope. So if I have line here, line 1, and it is y equals 2x plus 1, and then I give you a second line, and y2 is equal to 2x minus 3, I can ask the question, are these lines parallel? Well, you should be able to say yes. And then when I say, prove it. How do I know you're not guessing? Prove that you know they're parallel. Your answer would be because they have the same slope. And lines that have the same slope are parallel. It's one of our theorems that we have. And here is an example of the two drawn. You can see they're parallel. They are never, ever going to intersect. Now, perpendicular lines have slopes that are negative reciprocals. It's really interesting. In geometry, the formal language is the product of two slopes of perpendicular lines is equal to -1. Again, I've never done that. I know it. I have it memorized. I've been a teacher. But when I was in school, I never thought, do these two numbers multiplied together equal -1? No, I didn't. What I would do is, if this is my first one, y1, that has a slope of 2/1. The slope of any line perpendicular to it, I'm going to flip the fraction and change the sign. So any line perpendicular to y1 has to have a slope of -1/2. I go up here and I double check the slope. It's -1/2. Yes, these two are perpendicular. Now again, if I multiply 2/1 times -1/2, I do get -1, but it's just a whole lot easier to flip it and change the sign. Now there's two ways to graph a line as well. you can create an XY chart. This is my favorite way. I like this just because I've done really higher order math, and I can use an XY chart when I'm doing circles, when I'm doing ellipses, when I'm doing parabolas, and especially with a multiple choice test, I can get a good idea of which answer is the correct one by doing an XY chart. XY chart is going to look like this, where you just do the little table and you do XY, and you just go, let me just pull out of thin air a number for X. Let's let X equal 0, and I solve for Y. Another way to graph it is to put the equation in Y equals mx plus b form. Then you have the y-intercept and you have the slope. And so you can kind of count over from that point and get a second one. For ACT timing purposes, y equals mx plus b might be quicker to use. Again, if you're better with the XY chart, use the XY chart. If you're better with y equals, use y equals. Whichever way is faster and comes to your mind first. So let's look at this example here. Okay. Here it says graph 4x plus 2y equals 6. Now, we'll go the book way. The book is going to change this into y equals form. So we're going to move this negative 4x over. And now we need to divide both sides by 2. So they go through here and divide everything by 2. And so we get a point of 0, 3 with a slope of negative 2. And you can see here on the graph, here is 0, 3. And I can go down 2 and over 1. There's my second point. And you draw a line. And that's your first postulate in geometry. Through any 2 points, there's exactly one line, so we have to have 2 points. We have to have 2. Now, let's look at this from an XY chart. Okay? From an XY chart, I'm going to look at my original equation here, and I'm going to go, I need to pick a value for either X or Y and solve for the other one. Where am I going to pick this value? Out of thin air. I can pick whatever number I want. I'm going to go with X first because X comes before Y. And I'm going to pick a value for X. Again, I can make it be 1,000,000. I can make it 0.25. But I've done enough math equations. I'm going to work smarter, not harder. And I'm going to pick 0. Why? Because anything multiplied by 0 is 0. Anything added to 0 stays the same. It's easy math. So I'm going to say, let's let X be equal 0 and find out when X is 0, what's the Y coordinate? What's really, really interesting because, let me get a different pen color. Okay, so if you look here, if I let X be equal to 0, then this would be 4 times 0, which is 0. So it kind of gets rid of that. And now all I have is 2y equals 6. Divide both sides by 2, and when X is 0, Y is equal to 3. Yeah. Pretty cool. Now, on the next one, I'm going to do, let's let Y be equal to 0. I like using the zeros. And so when Y is 0, 2 times 0 is 0. I get 4x equals 6, and when I divide, I end up getting 3 halves. Well, that point is here. Okay, X is 3 halves, Y is 0. I can graph it. Now, if you don't like fractions, which I don't, I really don't, and if you're ever doing this on a computer, it's a little hard to do fractional coordinates. If I've used both my 0 zeros and I've gotten a fraction, then I'll go, what's better than the next best thing to 0? Let's let X be equal to 1. Because add 1 to anything, that's easy. Anything multiplied by 1, it stays the same. So I'm really good with that. So let's go here. If X is 1, that makes this 4 plus 2y equals 6. When I subtract 4 from both sides, I get 2y is equal to 2. Therefore, y is equal to 1. And there's 1 comma 1. You can see that points right here. And I can draw my lines through. Sometimes it's good to do a third point just as a double check, but it's not necessarily a have-to situation. Okay, here is our ACT example. So just pause for a moment. Again, take about 5 to 10 minutes, work on this, look back through your notes, and see if you can answer it. All right, welcome back. For this one, this is where you have to use that equation that slope is equal to y2 minus y1 over x2 minus x1. And of course, I do things just a little different when I'm not required for speed, accuracy, and just like the distance formula, I will stack these. Because I know I need to subtract my x's and my y's, and this helps me keep them in order. So -3 minus a -1, that becomes -3 plus 1, so I get a -2. 2 minus 4 gives me a -2. Now what I need to remember here is it's rise over run. This is my y, this is my x, so slope is going to be equal to -2 over -2, which is equal to 1. And yes, that is my answer. Okay, you've only got 3 questions. I've got 6 in here because I went over a couple extra in class, but you've only got the first 3, so set 3 minutes on your clock and unpause when you're ready. Okay, let's get back. So the first one, what is the slope of the line? I'm going to stack my 2 coordinates. 5, 4. So -3 minus 5 gives me -8. 1 minus 4 gives me -3. I have to put my y, rise over my run. So I get -3 over -8. Negative over negative makes them positive. So the answer is 3/8. The next one, oh, it's really cool. I love problems like these. We have to remember that it's rise over run. So it's literally 3 over 5. They gave us the numbers. They gave us the distance. Big trick here is remembering rise over run. This next one, this one says, let me move me a little here. They've given you the equation of a line. You need to be able to identify that 0.15 is the slope. And if they want a slope that's 0.2 greater than this line, you just have to do 0.15 plus 0.2. And that gives us 0.35. Now I'm going to show you these other ones because they're really good to know for the ACT, but more importantly for geometry class. Here they're asking which of these lines is perpendicular to the one given here. We need to divide both sides by 2 so that we get it in true y equals form. So we get y is equal to 3/2 x plus 1/2. And what we're concerned about is this 3/2. The slope is 3/2. So any line perpendicular to it is going to have the negative reciprocal slope. So we flip it and we change the sign. So any line perpendicular will have a slope of -2/3. So now let's go over here and find which one has -2/3 as its slope. G. G for got it. Yes. Here, what of the following is the slope of a line that's parallel to this one? They just want to know if you know that's the slope and parallel lines have the same slope. So if that one has a slope of 1/4, the other one is going to have a slope of 1/4. Now this one, they want to know what is another point on this graph that is with 4, 5 with a slope of -3, 4. This would be one where I'd sit here and go, okay, let's go down 3 and over 4. Ooh, it didn't meet anything. So let's go up. Let's go what? Over 4, up 3. So that answer is point D, 0.8. And this one, this is where the whole positive and negative slopes, knowing what the graph looks like, comes in handy. Because if we take this equation here and we put it in y equals, you're going to get y is equal to 2x plus 1. It's a positive slope, so that means it's going upstairs. Can't be D, can't be E. Those are negatives. Now I can go over here and I can plug in some points if I wanted to. I can plug in 1, but I'm just looking for something that's going up 2 over 1. Here we're at -1 and 1. That goes up 1 over 1. That's a slope of 1. This one goes up 2 over 2. That's the slope of 1 again. Process of elimination, it's A, and you can look, this is at 1/2. It goes up 2 over 1. Goes up 2 halves and over 1/2. That's our answer. Okay, so now you've got the exit ticket. You've got to complete that. If you look on your exit ticket, I got it upside down. Yeah, so your exit ticket here, you've got 4 questions. You need to take this from standard form to y equals form. From that y equal form, you should be able to identify the value of the slope, tell me if it's positive or negative, and give me the y-intercept, which is B. If you do not know the answer, again, shoot me an email. You need to ask questions, and I'll be more than happy to try to direct you in the right path. Have fun.